All right. Well, it's 2 minutes early, so if you're watching this in the future, you might want to just fast forward a little bit. But I couldn't wait. I don't know, nothing better to do. So, good evening. I'll start like for real in like when my clock says 7 o'clock. I just, like I said, just kind of like getting some things going, hoping I'm actually here today. I think I actually remembered to push the right button and start the actual live stream. So I'm just checking out the last couple last minute dealy bobs here. But it looks like we're good. So my lighting in the room is about to change at like 7 o'clock. So like that's how I'm gonna know it's exactly 7 o'clock. It's gonna, hey, good evening. That's how I'll know it's exactly 7. But just making sure everything's working, saying hi. I might even cut this part out and then, yeah, I don't know. I could trim it later, but you could also just fast forward through all this part. Let's see. I don't want to see too much of importance, but I will just point out what it says on the screen. I'll say it again. Write some stuff down. Be engaged with this. I got a request for one of the to answer one of the questions on the review. I'll do that. Of course, it has to do with projectiles launched at an angle, so I'll get to that too. And yeah, but well, like I said, I don't want to get too crazy just yet, too into it, because it's not officially 7. Just saying hi, making sure things work, you know. I'll be back in the classroom on Tuesday, I think, is my official day to start. Mr. Kelly's official last day is tomorrow, I believe, at least in the classroom. I think he'll still be around, but hey, my clock says 7 o'clock, and there's my lights. Let's turn those back on. All right, now I can officially start. So I'm just messing with my phone because I got Remind up. If you got questions, you can either ask them via Remind, or you can put it in the YouTube chat if you want to. But just like last time. And I did get the feedback about the live stream. I'm always I do this to be helpful to you. So if I'm doing something that could be done a little bit better, please let me know. I will not take offense. You know, I am not a master of live streaming. I have just done this a few times for a few years, and I have tailored it based on what my students want. You guys are my students, and so I want to do what helps you. Maybe not so much what you want, but what's going to be helpful to you. Oh, wonderful. Well, this was working just fine a moment ago. Let's do something real quick here. So, monitor, okay. Is monitor 2. All right, this should do. Let me just unplug something and plug it back in, because it's just not working exactly how I want it to. There we go. All right, there's my. Yeah, see, I started early, and here I am, still messed up a little bit. All right, cool. So I think we're good. Let me just pick my pen color. I don't like the default color is red. Let's go with this little blue color. Cool. So like I said, it says it on the screen too. Be ready to take some notes. Do something to be interactive here, right? Having this on in the background is better than nothing, but being like involved with it, being engaged is going to be really helpful. Hey, and for you, like this is not a magic bullet, as you may have found out last test, right? So just watching it is not going to be like the magic thing that makes you be really good at this stuff. So be engaged, take some notes or something. And like I said, I might have said this when I was officially live. I'll say it again. Chat here, YouTube, or you can use Remind to ask me questions. If I'm looking over that direction, it's because that's where my phone's at. If I'm looking over in that direction, that's another screen over there. All right, let's get going, right? There's 4 sections to this unit. The last 2 are sort of combined. The first part of the unit is 3.1. It's a horizontal projectile motions. Horizontal projectile is launched at a starting horizontal, rolling off a table. It's going sideways to start. It is not launched at an angle. It's going sideways only. So first question, and I counted, there's about a 9 or 10 second delay. Yes, get smart. I will get you smart. So how much does horizontal velocity affect the pull of gravity on a thrown ball? In other words, you throw a ball sideways, horizontal, because that's going to be the focus, just straight up horizontal. All right, got some answers. Perfect. Throwing it side to side, horizontally, how much does the speed of the ball affect the pull of gravity? I already got somebody saying D. Do you guys all agree on that, or what? What if you throw it faster? What if you throw it slower? What if it just rolls off the table? What if you push it sideways off the table, right? All these things to keep in mind. But the answer is we're talking horizontal. So that's supposed to be directly to the side. What direction does gravity pull? Gravity pulls downward. If you want something to speed up and it's going to the side, you need to push in the same direction that it's going to make it speed up. You're getting it. If you need something to slow down, you need to push in the opposite direction for it to slow down. Gravity pulls 90 degrees to that. Gravity does not pull or push to the side at all. So the answer is, as you guys are saying, D. Horizontal velocity never affects the pull of gravity. Okay, they are completely separate. Completely separate. Okay, stop me if you got questions. I will always gladly go back. So the flip side of this question, how much does the pull of gravity affect the horizontal velocity of a thrown ball? Okay, in other words, you throw a ball to the side. How does gravity affect the speed of that? The horizontal speed. Okay, not the overall speed. How does gravity affect the horizontal speed? Horizontal velocity. Well, like before, if you want this ball to speed up to the side, you have to push it to the side. If you want the ball to slow down to the side, you have to push backwards to the side. And C is interesting choice, right? Because technically you'd be correct, except we're talking about gravity. We're talking about gravity. And what direction does gravity always pull? Downward. So your logic, your reasoning behind choosing C is okay, but there is no horizontal component of gravity. All right. You are, like I said, you're kind of sort of correct only if there is a horizontal, but it's gravity. Gravity only pulls straight down. So if I say gravity, you could just automatically say, okay, there is no horizontal component. I'm trying to make you like, I put that there because we have a tendency to overthink things and just be kind of wary of overthinking things. Gravity simply pulls down. You might be like, well, what about those caves in like South Carolina? No. Don't worry about like the weird like stuff. Just gravity pulls down, all right? Gravity pulls down. When a projectile is launched horizontally, okay, still horizontal, what variable do we always immediately know? Variables. What variables do we always immediately know? And it's always going to be the same if it's launched. So like whether you're throwing it side to side or here's a table, the ball rolls off the table, right? That's my table. So the ball rolls off the table, you throw horizontally. What do we automatically know? Ooh. Okay. Let's break this down a little bit. What do we automatically know? What is automatic? Automatic, we actually don't know the dx. Dx is how far the ball rolls. That actually could be a question mark. We don't know necessarily how far the ball rolls. So no, we don't automatically know that. Great guess though. Do we know the wow, I cannot talk tonight. Do we know the Vx? Do we know the horizontal velocity? No, it could change anytime. We might be given it, but I'm saying like what is like automatically always like the same for every single horizontal projectile motion problem, every single one. So far, not these two. We do know C because C is always going to be 0 meters per second squared if you want. Okay. You can't retract messages. We already know you put the answer, but I understand. Yes. Okay. You just hit the wrong button. Okay. We always know C, but there's more. But wait. Do we know dy? No. dy is going to be how, like, let's see if I can do this. All right. That's fine. dy is going to be how far the ball falls straight down. We don't, I mean, who knows? That we might be given it, but we don't automatically know that. All right. Good, good, good. Yep. AY. All right. Good. AY is automatically negative 9.8 meters per second squared. Always gravity. Nice. There's one more that we always know. If it's horizontal. All right, I got it. Ready? It's not time. It's v, the initial velocity in the y direction is always 0 meters per second. Yes. Good. With the delay, you got it in time. All right. That is the key to horizontal projectile motion. Okay, that's always going to be the case because it's horizontal projectile. You know these three things. The other two are these two are gonna be the same for any projectile. All right, any projectile. So for these two, okay, because a projectile by definition is something, anything that's under only the influence of gravity. We're ignoring air resistance, okay? So don't overthink that. We're ignoring air resistance because if you take physics later on, like in a couple of years or whatever, there's like an easy way, not easy, but it's a simple method of adding in air resistance. So we're gonna ignore that for now because it's too complicated for us at this point. So projectile is anything that's under the influence of just gravity. So it's always going to be, since there's nothing pushing it to the side or accelerating it to the side, it's always going to be the AX is going to be 0. In fact, you could probably just ignore that from now on. You don't even have to write it down if you don't want to, but maybe just do it just because, you know, we get the pattern. And because it's gravity on Earth, we're going to have the negative 9.8, the negative meaning downward. Now the horizontal, like I already said, is because it was just rolling off the table or it's thrown to the side. And so the initial vertical velocity is 0 initially. And then it starts to change because it eventually, not eventually, but it immediately starts to get pulled downward. But the initial vertical velocity is 0. Okay, so just remember those three things, always the case for horizontal projectile motion. All right, these are the equations on the equation sheet. You'll get the copy of that during the test on Tuesday. In fact, spoink, there they are, right? So right near the top, equation sheet is gonna look like that. These are all the equations. And so let me just, okay. So I pasted those here. If you know the height of your horizontally launched projectile, what equation would you use to find the time in the air? Okay, this is always the case. And the answer to find height, if you know height, is always going to be this. Good. For a horizontal, why? Because on the equation sheet it says if VIY is equal to 0. And like we just got done saying, VIY is equal to 0. So we can use this one for horizontal projectiles. Okay, because it just rolls off, or just there's no initial vertical velocity. Yep. I'm just telling you the patterns. Okay. So this is the y direction. All right, we know information up and down. There's no mystery. We're trying to find the time. What if we know the horizontal distance? Okay. So this was height. This was, well, we know the height. That's the y direction. I should have read it here. That's kind of confusing. We know the height. That's the y variable. Now we know the horizontal distance. So here's our ball, and it was initially like a, we know the horizontal distance, which is dx. Okay, now we're talking the x. So there's a pattern here. If you know the horizontal distance, then the answer is A, always, okay? Why? Because this is V average in the x direction, which doesn't change, okay? And this is dx, you know dx, and all you gotta do then is solve for time. There's no A, there's no acceleration, it's 0, so you wouldn't use You might be able to, you could probably use some of the other equations. There's no problem with that, I think, because like, it doesn't matter, but you could use others, but it's a safe bet that if you're dealing with X, you can use this first equation. All right, now I put an X there. That didn't mean it's wrong. I mean, like, that's the horizontal. It's the only one that doesn't have, well, this one does. It doesn't have acceleration component, and it doesn't have a changing velocity like this one does down here. All right, so to simplify what I was just saying, to summarize it, you know horizontal, you can use this equation to solve for whatever, time, whatever. Okay, that's the pattern. Just little things to keep in mind. All right, these are not things that I expect you to necessarily memorize. It's just there's a pattern as you do these in the practice. This is the pattern that you might notice, okay? And maybe knowing this pattern going forward will be helpful to you. All right, if you know time. So now we've got time, because remember, going back, well, I'm not gonna go back. That's the first step. Whenever you have any kind of projectile motion, the first thing you do is find the time, okay? So the two previous questions, how do you find the time? Now, you know the time. What should you use to find the distance something fell? Distance something fell is going to be, yeah, I mean, you could probably just use C. No problem. All right. Because you could just put the little y there, a y, and vi y. You know those units, those variables. You know the time. And so you could use that to find the distance, the dy. Okay, you can't use dy because we don't know vfy. We don't know the final velocity. It's just not given. So you might be able to use some other ones. I don't know, but okay. But bottom line, that's the pattern. You may have noticed, oh, I'm always using this equation. Whenever I'm trying to find the distance something fell, that's the y direction. So whenever you have the y direction, you're going to use this equation to find the distance. Okay. What about the horizontal distance? Once again, what's the pattern here? Clue here is in horizontal for a projectile, in the horizontal dimension, there's no ax. Ax is 0. So you may have noticed as you do the problems that this is going to be the, would that work? To find the horizontal distance. Well, that actually would, believe it or not, work. So you can use that as well. Because what's going to happen, this AB is a 0. And so that's all going to be 0. And so you can multiply V times T. So basically, yeah, either one of these works. And that's the wonder, that's the beauty of math. This actually is just a rearranged version. That's supposed to be an arrow. Rearranged version of each other. So if you do like D, if that multiplies out to 0 because A is 0, V times T, well, that's the same thing as, it's just a rearranged version of that. So it works out. All right. Not only that, but well, yeah, there's a few things. Actually, D would work as well if you knew VF. Typically, we don't. Okay, actually, we do because it doesn't change. It's going to be the same, but you could use that as well if you want. But I would focus on using A and or C to find those. Again, it's just a pattern. Are there any questions about the horizontally launched projectiles? Because guess what I'm going to talk about next? Angles. And I think I'm going to work one out for angles. That's not a problem. I'm not seeing any questions in the remind. All right. If you do have any, let me know. I could always go back. Not a problem. I'm here to help. The whole point of tonight. Okay. Launched at an angle. Ignoring air resistance, what angle should you throw a ball to make sure it goes the farthest? I'm going to demonstrate this to you. We're ignoring air resistance. We're ignoring air resistance, okay? A little simulation. Okay, you got the answer, 45 degrees. But do you know why? Let's see here. Control Z. Okay, I made a change. I need to undo that change. Why? Okay, this simulation lets me change a cannon to I got to scooch that up, I guess, so I could get a 0. All right, let's do 0. Okay, move that down to, nope. All right, 0 degrees. When you launch something at 0 degrees, straight horizontal, you could ignore, can I move the guy? No, I can't. All right, what happens? The initial velocity is 100% horizontal. It doesn't go very far, okay? When you launch at a 90-degree angle, the initial velocity is 100% vertical. It doesn't go very far. And honestly, the only reason it went far at all at a 0 degrees is because I had it off the ground. So it literally just like, if it was actually even with the ground, it would immediately hit the ground and bounce or whatever. If I go to like a 60-degree angle, that's mostly vertical. Let's go about 60. All right, mostly vertical with a little bit of horizontal. Boom. Okay. And if I go at a 30-degree angle, it's gonna be interesting because I'm off the ground, but we'll see what happens. It's the same proportion. Yeah, it's roughly the same. Now it's a little, it's off the ground, so it's a little weird. In fact, I'll just leave it there. But if I go at 45-degree angle, it's perfect mix of horizontal and vertical. If I go even 1 degree higher, that's a little bit too much vertical, so it goes higher, but it doesn't get as quite as far. If I go 1 degree less than 45, it goes faster to the side, but not as high. And if I were to zoom in on this, you would see that that the 45-degree goes the farthest. In fact, if I was kind of, let's make this a little bit smaller so we can differentiate between them. I'll clear this out. I'm going to put this down to the ground, so I can't go down to 0 anymore, but you understand the point. Let's do the 30. So mostly horizontal, so it's going very fast to the side, but it didn't get up very high, and so it hits the ground before it gets to go very far. 60 is the like inverse of that, so it goes really high, so it has time to travel, but it's not going very fast to the side, so in that time, it just didn't make it very far. 45 is the perfect mix. I know I'm repeating myself now, but like I just wanted to show you. One more than 45, go 46 degrees. You get the point here, I think, is it went up a little higher, but oh well, you get the point. 45 degrees, all right, is the answer. All right. So I will write that down to make it official. 45 degrees. The perfect mix of vertical and horizontal. Okay. I lost my chat, so let me just bring that up. Yes. This is a test question, right? It'll be something it's very hard to ask a question. This is a test question, or at least some version of this. Okay, knowing 45 degrees is the, with no air resistance. Easy test question, right? Easy test question, I hope. All right. Here's one to overthink. When is the acceleration due to gravity for a projectile 0? God of War is on my list of 3. But I don't think it's less fun than that projectile motion game. How many questions on the test? That's a fantastic question. I'm gonna have to get back to you on that one. And I won't forget. Okay, I'll if I don't remember now, because I have to look it up. I'll be honest with you, I don't know. There's FRQs. Okay, yeah. So here's the answer. The acceleration due to gravity. Okay, what is the acceleration due to gravity? Okay, just cut off the question at that point. What is the acceleration of gravity? The acceleration of gravity is negative 9.8 meters per second squared, right? So at what point is the projectile not under the influence of gravity? You don't want to get rid of the FRQs because you get partial credit for the FRQs. Okay, you're not just right or wrong. Okay, with the FRQs, trust me, you don't want to get rid of the FRQs. Even if you just write a beginning on an FRQ, you write down what you know, you'll get some points for it. So you don't want to get rid of the FRQs. But I'd say we could discuss it, but really we can't make a call here because it's up to the district, and it's not even my decision. All right, so the answer, it's never 0 meters per second. All right, because the acceleration of gravity is that g, lowercase g. That's that negative 9.8. It's always 9.8. I told you, this is one to overthink. So don't overthink it. The acceleration of gravity is always negative 9.8 meters per second squared. Read the question. Be careful. Next question. At what point is the vertical velocity of a projectile 0? Oh, it's not the same question. The vertical velocity. All right, vertical velocity. Vertical means up and down. So at what point does it ever get to be the point where it's 0? The answer is yes, at the top of the path. All right. It goes up at the beginning, down at the end, and at the very top, it's 0. So this is a vertical velocity. This is a positive vertical velocity here. This is a negative vertical velocity, Vy. Okay, vertical is the y direction. And at the top here, it's not going up or down at the very, very top. And so the vertical velocity, the speed the up and down speed is 0. Now, the Vx is constant. Okay, that's not going to change the entire time. It's you can see the little blue arrow. It's like, well, actually that's not the velocity. That's not representing the velocity. That's looks like this blue arrow is representing the displacement, the dx, but it's not shown. But the Vx never changes. But the vertical velocity never changes. Is always changing. It first is positive and then it's negative. Okay, that's okay. Hey, remember what I said last time? Get it wrong here, get it right on the test. So to recap, make sure you look at these two. This first one before, number 2, was asking about acceleration. Due to gravity, I even say it right here. What's causing it to accelerate? I hope that's a good thing. I'm going to have to look that one up. This one's asking about velocity. Okay. If the horizontal velocity of a projectile is 2.4 meters per second, what is the horizontal? The video right below this. That's funny. For you, remember, this is customized. Ain't for me. I'm going to have to look it up, though. All right. Well, maybe it is. I guess I haven't checked. It's not there right now. Great. Yeah. All right. Horizontal velocity. This is where you're going to start to, your brain is going to turn to mush at some point, right? On the test, you have the ability to flag questions and come back to them. Okay. I'm not saying this is a hard question. In fact, I'm going to say this is one of the easy questions, but I'm going to say flag hard questions and come back to them. Go through before your brain turns to mush and answer questions like these. Flag the hard questions and come back to them. The horizontal velocity, Vx, never changes. So, yep, you said it. If it starts out at 2.4 meters, right? Well, that's fine. I wish I had I wish there was a way to flag hard and really hard questions. But yeah, I know. It's okay. I know. This was a little rushed test, but just do the best you can. Do what you can on this, right? Do what you can. So the horizontal velocity never changes. If it starts out at 2.4, it's going to end up at 2.4. You already know more than you did starting this. You already know more. All right. Put a little star by it. Go back to the video. It was, I don't even know, what is it? We're 27 minutes in, right? Well, my favorite Thanksgiving goof has got to be me. That was a joke. Thank you for laughing. Food. Man. Not turkey. Turkey's all right, but it's not my favorite. I don't know. Yeah, thank you. Don't. It's okay. Hey, look, I'm wearing my NASA shirt. Ooh, I almost dropped my writing pad. Yeah. All right. Not changing the subject though. No, turkey's good. Turkey's good. I'm not. All right, let's take a look at this. Where were we? All right, calculating the time. Favorite Thanksgiving food though. Honestly, I kind of like the canned cranberry sauce, but you know, mashed potatoes is good. Gravy, we'll see. I don't know. Time. You know the initial vertical velocity. Okay, if it was horizontally launched, it would be F. Yeah. Because we can't use this last one because we've got this little if VI is equal to 0, and it's not, right? Because if it's launched at an angle, we gotta do this little thingy. The VYI is not 0. That's like the definition of this, right? Of the setup. So we can't use F. So the answer we're going to use, would that work? So D would work if we knew VF. Let's see, would that work? Oh, yeah, we know that. The thing we're probably not going to know is the distance, the displacement. A lot of times we don't know that. So maybe we can use D if we knew, or maybe we can use D if we knew D, if we knew the distance. But a lot of times we don't. And so same thing with C, exactly. We might be able to use this if we knew distance, but often, again, these are going to be dy. These are going to be heights that it gets, and that's not often. We don't know, like how high up do you throw a ball? I don't know, right? A lot of the questions. In fact, I'm pretty sure one of the questions it's going to ask is how high up did the ball get. So most of the time we don't know those. So I'm going to kind of put like a no on that. Well, you know what? No, I'm not. I'm just gonna leave it alone. Eraser. There we go. But the answer is going to be B, because here's why. I'm going to start with the easy one. Well, not the easy one, but we're going to know VI. Okay, that's going to be this right there. We're going to calculate that. It says we know time. No, we're calculating for time. So this is going to be our little question mark. Okay, we know acceleration is negative 9.8 meters per second squared. And VF, this is the fun thing, is VF is going to be negative VI. Why? In other words, this is the thing where it basically, when a projectile goes up and back down, the initial velocity in the y direction, it's going to come back down at the same exact speed. So the final velocity in the y direction is going to be the same. So something goes up, it's going to come right back down, even if it's at an angle. If it goes up at a certain speed, it's going to come down at that same speed. So we'll know VF because it's negative VY, or we'll know VI. It's negative VI. All right. When I get to the example, I'll explain that a little bit better. And C probably wouldn't work, like I said. And A wouldn't work unless you know the average velocity, which we usually don't. So the answer is B. I'll show you that in a few minutes. Okay. The final vertical velocity of a projectile like the one in the animation. Okay, I kind of just talked about this. How do you find the final vertical velocity? Vertical velocity is y, and we're talking the final vertical velocity. What did I just get done saying? The final vertical velocity is equal to the negative initial vertical velocity. In other words, like I said, it's going to come down at exactly the same speed that it went up at. Okay? It's going to come down at the same speed it went up at. So you're right, partly. So we're going to eliminate the ones that aren't negative. Okay? 0 would be the vertical velocity at the very top, like we talked about. Okay? So it can't be E. This would be E. We're talking about what is the velocity right here, just like the split second before it hits the ball, right? So it goes up and it comes down at the same exact speed. How do you figure that out? Well, we got our little equation here, our little triangle. This is our adjacent, this is our hypotenuse, and this is our opposite side. Yeah. And whenever you're dealing with, so this is gonna be our V, or velocity. So whenever you're dealing with opposites, if you remember, what's wrong? What's going on here? Why is it not B? So hang on, I may have made an error. Let me just erase this because now I'm not sure. So Ka, well, TOA, but we don't use TOA. We've maybe used it once. O stands for opposite, A stands for adjacent. All right. So if we're dealing with the opposite side, that means that we're going to end up using cosine. So it's got to be that one. No. Yeah, no. Why am I confused here? This is not supposed to be confusing because I'm talking in sort of abstracts. It is the opposite side. So it's opposite. O stands for opposite. So that's sine. S stands for sine. C stands for cosine. Yeah. I don't know why I have trouble with that one. You know what? There's not going to be a question asking for the specific equation. This is just like in general what equation you're going to use. And in fact, on the board for the test, we're going to have those equations where it's going to be we're going to have this on the board. Vx is equal to h times cosine of theta, and Vy is equal to h times the sine of theta. Yeah, so I was correct. We're going to have these on the board. Okay, so you won't actually even have to memorize them at all. So that's where letter D comes from. Negative V, the velocity, that's the hypotenuse. All right, sine of theta. All right. The key here, the thing to take away is it goes up just as fast as it comes down. Okay, if you need to like do a memory purge the last 2 minutes, do that. I don't know if that was helpful to you or not, but you know, okay, let's get to the example. So somebody sent me a request to do question 8 from the review guide. So this will take a few minutes to show you. It's not a problem. I want to show you how to do this, right? So Leo and Noah are playing catch. Leo throws the ball with velocity of 14.5 meters per second at an angle of 40 degrees to Noah and hits a crazy low-flying seagull after traveling a horizontal distance of 6 meters. How high up was the seagull? All right, let's start with all right. Well, you could solve it and come back to it if you want to, right? So if you want to work through this on your own, I don't think maybe I should come back to this. Let me come back to it. All right, I don't want you to have to pause it or anything like that. I want you to stay with me here. So I'm going to come back to this at the end. That way you could work through it. You could just hang on and you don't have to ignore me. So I'll come back to questions about this. I'm going to talk about circular motion. Is that okay? I mean, am I making the right call here? I feel like I am, but all right, I'll give you a chance to solve this. Okay, I'll come back to it. I do promise, unless my internet like drops out or something. All right, let's talk circular motion. You're sitting near the center of a merry-go-round and your friend is sitting near the edge. Who has a greater rotational speed? It's really helpful to draw this to visualize it, all right? So you are sitting near the center. Oh, wow, you guys are awesome, kind of. Well, wait, it's all the same. Careful here. And this is important. I'm glad I asked this question now because you're not correct. All right, so you are A, your friend is B. All right, who has the greater rotational speed? Rotational speed is just how long does it take to go around once? How long does it take to go around in a circle? Okay, that's it. That's it. How long does it take? It's like RPMs. Think of it RPMs, revolutions per minute, okay? And so the answer is you both go the same. You had the same rotational speed. So this is the vocabulary word, rotational speed. Right, you were thinking linear speed, exactly. Okay, You can see now the delay because your message just popped up when I said that. It's like a 9 or 10 second delay. Right. So the vocab word rotational speed is just, like I said, it's RPMs. Think of, I can't help it because I don't know, like a record. What's a wheel? Let's think a wheel on a car or merry-go-round. Like how long does the whole thing take to spin around once? That's rotational speed. So now the question is, who has the greater linear speed? You in the middle or your friend on the outside? Or are you both the same? This one's B, all right? Linear speed is distance per time. You are going on the inside track. You're not going as far in the same amount of time. Your friend is going way farther around in the same amount of time. And so your friend is going much farther in a smaller amount of time. So linear speed is what we think of as like velocity, if you want to, but in a circle. Rotational speed from the previous question is just like I said, it's RPMs. It's how many times does it go around, like as a wheel. All right. Yeah. So there's a difference between the two. Good. All right. So if you need to go back and review this, please do. But I think there's notes somewhere linked. Well, I know there's notes linked on the OneNote. All right. Oh, my shield has just run out. Oh, well. All right. Question 3. A couple more. What will happen if the centripetal force acting on an object disappears? All right. Whenever you see centripetal, it looks like it could be related to circle. It starts with a C, right? It's a fancy way of saying circular. And I might be asking this question in a minute. I forget which questions I ask and which ones I don't. What direction does, well, let's just start with this. Centripetal force. All right, good. If you remember, I assume Mr. Kell, I wasn't there for this one, but yeah. Okay, it's gonna fly away tangent to the circle. I found this was like a quick Google search. And this is the best one I found, unfortunately, but I think it gets the point across. If that centripetal force is represented by the red arrow, the centripetal force, Ft, the tension of the string, okay? That's the centripetal force. Centripetal force is any force that's pushing something toward the center of the circle. It's always, I could spell. It's always toward the center. Always toward the center. That's supposed to be an E. Wow, this is bad. But you remember that. That actually might be a test question. That's supposed to be an N. That's supposed to be an E. Let's just, man, this is just a train wreck here. Center. All right. Centripetal force is always toward the center. Always. Remember that. Like I said, I'm just going to put an asterisk by that because it seems like an important thing to know. And it doesn't matter what's causing it, as I already said. In this example of this animation, it is some sort of Ft, some sort of tension force. It could be an applied force. It could be a normal force. It could be like in a washing machine or a dryer. There'd be a normal force pushing the clothes to the center and the water toward the center, keeping it from flying outward. That's centripetal force. And as soon as that centripetal force is gone, objects in motion have a tendency to stay in motion in a straight line. So we're adding like a little bit to that. The only way something turns is if something pushes it toward the center. And as soon as that push is gone or that pull is gone, it's going to start going in a straight line again, tangent to the circle that it was moving. Okay? Tangent to the circle. That's it. That's how it goes. All right? If you are driving a car and you're turning the wheel and you let go, it's going to basically try to straighten out. If it can, it will. Because you're not holding the wheel. Okay? All right. Easy test question. Actually, there's probably like 2 test questions in here. Always toward the center, you know, flying away tangent to the circle. Okay. In fact, it just tangent. If you just kind of like remember that, that might be like, oh, that's that tangent word. if you don't remember what tangent is, the quick definition of tangent is basically just a straight line that touches exactly one point of a circle. That's it. So that's what tangent means. That's a tangent. I hope I didn't actually accidentally draw something bad. But that's what a tangent is. I can't imagine what it would be, but that's why I had to. All right. If you're running around a circular track at a constant speed, are you accelerating? And I'm going to preface this while you're thinking about it and possibly putting in an answer. Acceleration is change in velocity. I know. Acceleration is change in velocity. Is your velocity changing? Before you answer that, what is velocity? Velocity is a vector. Velocity is your speed and direction. That and. We didn't talk about it back, a couple units ago. But velocity is speed and direction. The definition of acceleration is changing velocity. Is your velocity changing over time? The question is your velocity changing? And the answer is yes. Because you're running around in a circular track. Your direction is changing. And if your direction is changing, that means your velocity is changing. And if your velocity is changing over a period of time, we call that acceleration. And so, yes, you are accelerating. In fact, there's a whole equation about it somewhere. No, I'm going to scratch that. AC, good, yeah, is equal to, crud, I don't remember exactly off the top of my head because for some reason I wasn't in the classroom. There it is, this one right here. This whole thing, changing velocity divided by the radius. So, there you go. Okay, yes, acceleration. Where was I? VC over R, I think is what it was. Don't quote me on that one. I think just, okay. You would think I would know this, but I also just double check. I'm like 90% sure. Okay. Yeah. I think I was thinking about force, but it doesn't matter. Yes. Okay. Now, what? This seems out of like left field here. If the moon travels around the earth 4 times in 100 days, what is its period? Reason I asked this question is there's gonna be a test question about this. Period of a circle is just the period of time. That's why it's a capital T. It's the period of time. I know. It's the period of time that it takes to go around once. So the equation for this one is just the time in seconds divided by the cycles, divided by how many times it goes around. Ooh, I know, right? This was on the practice for this. I know it was. All right, we know it went around 4 times. Okay, so that's how many cycles. It went around 4 times, so 4 cycles. Okay, you with me? And how many times did it go around? Well, it went 4 times in this many days. And the only hard part, well, there's a lot of hard parts here, is it's not in days, it's in seconds. And so on the board, I'm going to have this answer. One day, let's see if I can do this. Here, now you know what? I'm just going to skip it. No, I need to do this. All right, 109.2. So that's a weird number of days, but that's just how it is. So how many seconds is that? That's the question we got to answer. So the way we do this is I'm going to take the days. I need to multiply that by the number of hours in a day and multiply how many minutes are in an hour. Multiply that by how many seconds are in an hour. And I'm just going to give you, do you have to convert? Yeah, that's what I'm doing right now. So it's days times hours times minutes times seconds. So it is 109.288 days times there's 24 hours in a day, there's 60 minutes in an hour, and there's 60 seconds in a minute. And so if I could do 109.288 times 24 times 60 times 60. Yeah, that's how many seconds that is. All right. On the screen on the day of the test, I'll have information about how many seconds are in a day. I know. If you get stuck with anything, just let me know. Okay. So I take that 9,4,4,2,4,8,3.2 seconds divided by the 4 cycles. And when I just divide by 4, there's my answer. I'll write it down here. 2360620.8 seconds. That's the period. That's capital T. Okay. It's all in the review guide. Work through the review guide. You've got a couple days. I don't know what Mr. Kelly has planned tomorrow to review, but work on the review guide. Work through it. You got it on Friday. We both agreed that we wanted you to take this test before Thanksgiving because that's a 5-day weekend, and it's like, well, that means we got to kind of hurry, Mr. Kelly, and so he did. And so we're going to take that into account when we do the grading here. Just so you know, I know we rushed. You know I rushed. Everybody knows we rushed a little bit on this unit, and there's a lot to remember. So we're going to take all this into account when we do the grades. All right. Still do good on this. All right, because as you can see, the actual math is just little simple division. It's not that tough. All right. This might even be an FRQ. Honestly, this doesn't seem that. Yeah, that's exactly it. How many questions are we going to test out of curiosity? That question was asked earlier, and I don't know the answer to that one. I might be able to look it up later, but honestly, I'm a little scared that I'm going to pull the test up, and it's going to be like live stream. I'd really rather not do that. Yeah. One more. Well, then I got to go back and do the example. Oh, well, this should be easy. It is very easy to get stuff mixed up. That's exactly what I want to avoid is a test leak. So the direction of centripetal force, if you were paying attention, I answered this about 5 minutes ago, maybe 10. What direction is centripetal force acting on a revolving object? The answer is always inward. Okay, C. Always inward. You start to overthink it. You see the other ones like, well, maybe a little slightly to the, maybe a little, maybe this. No. Centripetal force is always directly toward the center of the circle. Okay, that's it. No weirdness about it. Now let's do this. All right, I dragged it over. All right, Unit 3 exam. I am opening it. You're hopefully not seeing it. It says it's opening, but I got a blank document. I did not open it. Oh, good. My computer's freezing. I'm gonna just let that think a minute. I might have too many windows open. All right. Before I move on to the example, any questions for me? Checking my Remind. I have the app. When I come back, I'll talk about Remind. I just assume everybody has the app, or you have it signed up on your phone to get Remind. I don't know if that's the case. Maybe it's just a bad assumption on my part. We'll see. All right, while you're thinking about that, I'm going to check. Nope, did not open it. Try this again. Review guide. I don't need that. Unit 3. I'll tell you what. Well, hey, there's my thing. Let's type Unit 3. Oh, wait. I'm giving myself exactly 30 more seconds. No, 20 more seconds. Momentum? Nope. Unit 3 exam, 2D motion. We might have a winner. All right. You're not seeing this, I hope. I got 25 questions. And then 3 FRQs. There you go. 25 multiple choice, 3 FRQs. Hey, friend from Providence. How's it going? All right. Yeah. Hopefully, this is kind of all right. Uh-oh. The fan war is about to end. I didn't take my turns. Man, I had to do a live stream. All right. Let's go through this review, or let's go through this question. Because I suspect this will be one of the FRQs. All right. Why are you scared? Don't be scared. 25 questions? All right, good. I'm gonna show you the answer now. All right. Oh, my voice got really deep there for a moment. Yes, and that's what you got to do. So what happens is I'm just going to be simple here. There's like a bird, woo, and I have no idea where it hits, but somewhere up here it hits the bird. All right. We want to know how high up it is, dy. Okay. You know what? I don't like that drawing. I tried to do that bracket drawing, and I'm very bad at it. So I'm going to do like the more like that. I'm sure that has a name, but I don't know what it is. How high up is it? That's the answer. Great. Yes. Nice. You got it. Very good. All right. So how do you do it? I do it by now. Okay. I'm going to start by showing you how did I show you this or Mr. Kelly? I don't remember. Yeah. I think I showed you. List all the variables. D, V, A, X, and then do the same for the Y's. Except this is VYI and AY, all right? Now this is like a little structure to help you because your math skill, you might not have gotten to stuff like this in math. And if you don't need to do all these little tiny itty bitty steps, you know, if you're more comfortable doing, not finding shortcuts, that's not what I mean. Like if you have a deeper understanding of this stuff, you don't necessarily have to do all this. There's just some things that I do because I'm not sure about our math. So these are the two things that we could always be sure of. AX is always going to be 0. And VYI is always, no, that's wrong. That should go here. Put that in the wrong spot. So I get for talking and being distracted while doing stuff like this. Be careful, don't get distracted. Oh, what do you know? We've got spam. I need to take care of this real quick. Yeah, I know. Your hide user on this channel. You hide these really quick. Yeah, they happen. I'm surprised, honestly, we haven't gotten more. I feel like almost like honored that we get spam. Yeah, it's totally spam. So I apologize about that. That's just the nature of the internet. It just kind of sucks, but it is what it is. So yeah, you just gotta learn to ignore it, deal with that kind of stuff, and move on, right? Where are we? Yeah, stop. That's not how you deal with it. All right, where were we? Okay, velocity of 14 meters per second. So what I like to do is just draw my initial V. All right, this is going to be like the whole thing about like so this is going to be VYI. This is going to be VX. Okay, this will be my theta. That makes this my adjacent side. That makes this my opposite side, and this my hypotenuse. All right. So what I'm going to have on the board is, first of all, dx is, yeah, don't click any links. Oops, I went too far with that because I'm looking over at your chat. Stop, just ignore it. Ignore it. All right. So this is going to be my dx. That's how far away the bird was, and it says that it was a distance of 6 meters. Okay, so I know that the seagull was 6 meters away horizontally. My Vx, that's going to be this right here. That's my adjacent side. And so, like I said, on the board, I'm going to have, what are we going to have on the board? I think it's going to be this. Vx. Don't click links. Was it your first day on the internet? No, it's not what I'm going to have on there. Yeah, back on topic. So adjacent, we're gonna have one of these useful equations on there. Cosine, so that's adjacent. That's gonna be cos, yeah. Cos of angle, and the opposite is going to be h times the sine of the angle. We'll have that one, and it might be like, it might be even better than that, but that's going to be the minimum. We're going to have this on the screen. So Vx is my adjacent side, so that means it's going to be h times the cosine of theta, which means it's going to be h is my initial velocity, the total velocity, so 4.5 meters per second. So it's going to be 4.5 meters per second times cosine of 40 degrees, which is 11.1. I've already worked this out, but I'll put that in the calculator. 4.5, I'll just do this one, times cos of 11. No, 40. Yeah, 3.4. What? What did I do wrong? So Katova, maybe it is 14.5. That's why. Thank you. There is a 1 in there I can't see. All right, I'm like, something ain't right. Let's see if I can just do this. No, wrong. I'm just gonna type it really quick. 0.5 cos of 40. There we go. I'm like, oh, that's not what I got earlier. All right, so write clearly. dy is going to be our question mark. That's what we're trying to find. How high up is this bird that we just hit? And thank you for the fix there. Vyi is going to be my opposite side. And so that's going to be h times the sine of theta, which is 14.5 meters per second times the sine of theta, sine of 40 degrees. I'm going to make this a little bit more clear up here. That's 40 degrees. And that will give me 9.32 meters per second. All right. I hope I have enough room. I think I do. Okay, we got lots of variables. Now what? Well, remember, what's the trick? Find time. So find time. And I know I taught this in the 6th period. I think that was what I did. That's why I was confused on whether or not I taught this to you guys or not. What I said there is look to see to find time, you got to use either x's or y's. Do not mix the variables. You cannot mix x's and y's. You cannot cross dimensions. All right. Crossing dimensions is bad. Crossing dimensions breaks the laws of physics. You can't do it. All right. So literally we have an x dimension and a y dimension. They do not cross. You can't mix them. All right. They're completely independent of each other. All right. So, right. So what do you do to find time? Well, whatever you have the question mark, don't use that one. Use the other one. So x, we don't have any question marks. And so, right, I'm going to, do you do the right one? Yeah, probably. That might work, but I'm not, I was going to be a little even simpler than that. I was going to do v is equal to d over t. And I'm going to use x's for that. So vx is equal to dx over t. And what I'm going to do is I'm going to multiply both sides this by t to get rid of that. And whatever I do to one side, I got to do it to the other. And I want to get time by itself. So now I'm going to divide that by vx, which will cancel that out. And if I divide that by vx, then I get time is equal to dx over vx, which is 6 meters divided by 11.1 meters per second. And the meters will cancel out, leaving just the seconds on the bottom that I just erased. And the bottom of a fraction becomes the top. And I got 0.55 seconds. That's going to be my time. And that's not the final answer, but basically the ball was in the air for a little over half a second before it hit the bird. Okay. All right. Now what? Well, we know how long it was in the air. So now the time is a scalar. Time does not have a direction. Time travels in all dimensions, like physical dimensions. It travels in X, Y, and Z. So time is directionless. So you can mix time with any direction you want because time doesn't have a direction, like a physical direction. So now we look at our equation sheet, and I'm not going to pull it up because then it would cover up what I got. But then the equation I'm going to choose is, and this was one of those you know what, I'm going to start without the y's. So d is equal to 1/2 a t squared multiplied plus vi times time. That's from the equation sheet. Why this one? Because I know acceleration, negative 9.8. Okay, so got to be clear, just to make sure we don't cross any streams here. We got to make sure all of our vectors are just the y's. If we have any x's, then the universe explodes and we fail our test. Okay, so dy, yes, I know dy. No, I don't know dy. That's what I'm trying to find. I know ay, we're good. I know time. I know viy, got that, 9.32. I know time again. So now I can just plug in those numbers and solve it. So dy is equal to 1/2, and I highly recommend parentheses and writing slowly. I highly recommend parentheses because it's going to keep everything all nice and bundled up together. So negative 9.8 meters per second squared times time squared, and don't forget, it happens. Can you get the right answer? No, yeah, and that's why. So it's going to happen. And this is probably going to be a FRQ, right? And if you get the time wrong, you'll lose 1 point out of all of them, like out of all the points. And that's way better than, I mean, double check, of course. Make sure you got to square this, by the way. Square it. Don't forget that square. That's also a place where a lot of people make mistakes, is to forget to square it. But if this is an FRQ, then if you get the time wrong, you lose one of the many points for this. VIY was 9.32 meters per second times the time again, and the time was 0.55 seconds. Now this part's pretty cool. I always like this part. dy, that's not the part I like. The part I like is how the units work out. These two are being multiplied together, acceleration and time squared. We're going to square this time. We're going to square the seconds, and we're going to get seconds squared right here. We got seconds squared on the bottom of the fraction right here. So seconds squared on top of the fraction is going to cancel out the seconds squared on the bottom of the fraction, leaving just meters, which is cool because we're trying to solve for distance, how high up the ball is. Over on this side, plus, you can only add like terms. It's a mathematical thing. We got seconds on the bottom, and we got seconds on the top right over here. This seconds is going to cancel out with that seconds, also leaving only meters. That's a good sign that we're doing this correctly, and we can add our like terms. And this is where we get 3.7 meters. Okay. Great. All right. Find time. Where should Noah have been standing to catch the ball if there wasn't a bird in the way? All right. I'll just say, I know there's like a 10-second delay, so if you got questions, pop them in there. It also takes time to type it. Please ask. Please ask. I can go back. While you're thinking about that, I'm going to switch colors maybe. Let's go with, I like purple. Let's do purple. Slightly different. Where should Noah, okay, so for this one, we're going to start the ball here, and it's going to go up, and it's going to go down. And I'm going to try to attempt to draw a straight line representing the ground. So here's the ground. The ball goes all the way up, and it comes all the way down. All right. If this first ball on the left is thrown by Leo and it is caught by Noah, where should Noah stand if there wasn't a bird in the way? All right, we're going to have all the same variables from up above, except for, so these are all going to be the same. Okay. I'm not going to redraw them all. But we also know one other thing. Well, we know a couple other things, actually. This goes from earlier. This is our VIY. How far up? We know that. So VIY is this 9.32 meters per second. But we also know that it's going to come down VFY, the final velocity. We know that the final velocity in the y direction. Wait, hang on. Let's do this. Let's try to be consistent here. I see a question I'm going to look at in a minute. Okay. It's tricky. Yeah, we're getting there. So, yeah, no, it's okay. This one is probably the most difficult one, all right, of all of them. And if this is enough RQ, get as far as you can, until you basically your mind melts and you forget everything. Is negative. It's negative VYI. So in other words, it's negative 9.32 meters per second. Okay, it's going down with the same speed that it initially went up with, except in the opposite direction. That's why it's negative. We know that. That's new. So what are we going to do with that? Well, that's going to help us to find time. Remember, time is our key. Time is the first thing we want to do. And so to find time, there's one equation that's going to work for us. And again, this just comes with practice, like doing the review guide. Look at all the equations. In fact, I will pull this one up. Maybe there it is. Which of these is going to help us to solve for time? All right, will this work? Look at that. Okay. Wow, I'm just like a technological wizard here. We want to find time, and so that's not going to help us. Okay, maybe this one will. Will this do it? So we know VF. I just wrote that VF. The in the y direction, we know that it's going to be negative whatever, 9.32. We know acceleration, negative 9.8. We are trying to find time, and we know initial velocity. Well, hey, it's going to be this equation. We are set. So let's do that. What? Mr. Jordan, I got lost. I know. It's okay. So I'm going to use the equation. I'm just going to go, let's go across. The equation is going to be, I'm going to write it down right from the equation sheet though. VF is equal to A T plus VI. Yep. Why? Because we know all the variables except for T. We know initial, not initial. I keep wanting to write I. What rhymes with I? Y. We know all of those. It's okay. That actually might work too. I didn't look closely at that one. Math, there's oftentimes more than one pathway to solve something. All right. So what I'm going to do is I want to get time by itself. So I need to subtract VIY. You could, here, I do it this way, but if you want to just plug in the numbers and solve for the missing variable, like solve for X, do that, okay? If that's how you prefer to do your algebra. I kind of prefer to do it this way, like solve for it ahead of time. Either way is fine with me. But that's going to get rid of that. But then whatever I do to one side, I have to do to the other side. So minus VIY. And then I want to get time by itself here. So I'm multiplying. So I need to do the opposite of that. So I'm going to get rid of AY. So I'm going to divide that out. And so I'm going to divide that by AY. And so what that ends up being is VFY minus VIY divided by AY gives me time. All right. And if I plug in my numbers for that, let's see if I could squeeze that in right here. Let's be an arrow. That's a horrible. It's supposed to be an arrow. Let's just erase that for clarity's sake. Okay. I'm not gonna be able to squeeze it in. Oh well, I'm gonna try anyway. Here, you know what? I could do it this way. Equals. There. See, I'm smart. VFY is negative 9.32 meters per second minus 9.32 meters per second. That does not cancel out because you've got a negative minus a negative. If you got -1 minus 1, that becomes -2. Just be careful. That does not equal 0 right here. And then you divide that by negative 9.8 meters per second squared. And when I put that into my calculator, negative 9.32 minus 9.32. See, I get a big negative number, divided by negative 9.8. And the negatives now cancel each other out. And so the time in the air, where'd my little pen go? There it is 1.90 seconds. All right, I'm going to put the little fluffy cloud around that because it's important, but it's not my final answer. The wowzers stands. There's a lot going on here. Like I said, this is the most difficult question, I believe. Okay. Now what? We got our time. Yay. That's what we wanted to do. Exactly. That's the time. That's how long it will be in the air if it goes all the way up and all the way down. All right. So where should he be? Yeah. So now we know, based on that time is equal to 1.90 seconds. We are trying to find from here to here, dx. All right. We're trying to find that. So dx is equal to our question mark. One other important thing, we already wrote it down. I'm just going to rewrite it again. Vx, we've got that. That's going to be 11.1 meters per second. You're getting distracted. Focus. I'm almost done. And then I'll be done. All right. So we need to solve for that. So we've got t, d, and v. So that's going to be velocity is distance over time. Okay. And that's straight from the equation sheet. That's the very first equation. We want to solve for displacement. So I'm going to multiply by t to get rid of that. On that side, whatever I do to one side, I got to do to the other. So times t. And so the displacement in the x direction is going to be, good call, times t. So I'm going to multiply these together. And then I'm almost done. I'm actually done with the physics. Now I just need to do the algebra. So Vx is 11.1. My dog just tried to bust into the room. She's not coming in. She's like, you're done, aren't you? I'm like, nope. And so that is going to be equal to, did somebody put, hang on. You put that answer before, because I feel like I saw that before. Seconds are going to cancel out, leaving only meters. So he went 21.1 meters. Would I just spend 15 minutes on that question, 20 minutes? But I was explaining it. It's 2 questions. Okay. What do you think? I put together this review guide looking at the test. Okay, obviously question 8 was asked of me, but all the questions I asked on the review guide were there because I was looking at the test when I made this. Okay, yeah. So Mr. Kelly gave you a practice. This was one of them. Mr. Kelly gave you a practice to review this. If you followed along with this and you want to try it by yourself, go back and do this, and then maybe go back to the practice from last week that dealt with this and try more. I don't know. If you did like the evens, maybe try some of the odds. If you did the odds, try some of the evens, right? So you could. There's plenty of practice to go around with this. But I should explain the question. But yes, well, yeah. But do the review guide. Like I said, I don't know what Mr. Kelly has planned for tomorrow, but please ask questions either in class. You could send me, you could send Mr. Kelly or both of us questions via email. I use Teams, so if you want to use Teams chat, You can use Teams chat with me. You can use Remind if you want to use that. Either one. So Remind, email, Teams chat, or in person. Be good. So try this. All right. This was the hardest one. This question right here, right? So I'm glad somebody asked me that. So thank you. Anything else? All right. Not seeing anything. Guess I'll stop here. All right. Test is on Tuesday. You've got time to get good. Got time to ask questions. I'll see you then. So have a good night. Thanks for joining. Hope it was helpful. Bye.